Okay, a proportion is just when you set ratios equal, and a ratio is just comparison of two items. So if I say x over 3 equals 6 over 9, what do you put in for x so this would be a true statement? Well, there's two ways of doing it. The long way or longer way is to find the LCD and multiply both sides by it. Lowest common denominator. We've been doing that for a week or two now. But whenever you have one fraction equals one fraction, the shortcut is to cross multiply. So x, the denominator of the first fraction, multiplied to the, excuse me, I said that wrong. The numerator of the first fraction multiplied by the denominator of the second fraction equals the denominator of the first fraction times the numerator of the second fraction. Then you solve it. So if you divide by 9, x is 2. And 2/3 is exactly the same as 6/9 when you reduce 6/9. So if I have x over 5 equals 16 over 20. Okay, so again, I could multiply both sides by the LCD, which happens to be 20. That would be okay if you want to do it that way. But when you have one fraction equals one fraction, you can solve it by cross multiplying. So x times 20 is 20x, and 5 times 16 is 80. Oops. Then to solve, you're going to divide both sides by 20. So x equals 4. So 4/5 is the same as 16/12 when you reduce 16/12. Now you could have x plus 1 over 6 equals, let's say 2/3. So again, you could multiply both sides by the LCD, which happens to be 6, or you could just cross multiply. So it'd be 3 times x plus 1 equals 6 times 2. I'll actually write it out this time for you. So it'd be 3x plus 3 equals 12. So then you want to get the x term by itself, so you subtract 3, so 3x equals 9. Then divide by 3, x equals 3. Okay, let's try another one here. X plus 2 over 6 equals, let's do 9/12. So I'm going to go z times z, 12 times x plus 2 equals 6 times 9. So I'd have 12x plus 24 equals 6 times 9 is 54. So subtract 24 to get the x by itself. So 12x equals 30. Now, you're going to say, oh my goodness, Mr. Murphy, we have fractions. 6 goes into both, so it'd be 5 halves. Well, fractions are okay. Fractions are our friends. Now, if you want to change that to 2.5, that's okay. I like improper fractions. I know middle school teachers don't, but I do. Okay, we're going to make it even more difficult. X minus 1 over 4 equals x over 5. Holy moly, moly, holy. These are getting tricky. So again, you could multiply both sides by the LCD, which 4 has 2 2's, 1 5, so it'd be 20. 2 times 2 times 5. Or you could just cross multiply when you have one fraction equal one fraction. So it'd be this times this, so it'd be 5 times x minus 1 equals 4 times x. So distribute the 5. 5x minus 5 equals 4x. So I'm going to subtract 5x to get the x's to one side. So negative 5 equals negative x, or negative 1x, however you want to say it. Divide by negative 1 or multiply by negative 1. Either one works. So 5 equals x. Hey! Try 2 for me, please. Do x plus 3 over 6 equals 1/2. And do x plus 2 over 4 equals, we're going to have you do 3, just for fun. Let's do 6/12. And then, the trickiest one yet. X over x plus 1 equals 4 over 5. 3. So try those 3 and then turn me back on. Okay. So, again, you can multiply both sides by 6, the LCD, or cross multiply. You have 2 times x plus 3 equals 6 times 1 is 6. So 2x plus 6 equals 6. Subtract 6, you get, I'm going to bring this over here. 2x equals 0, because 6 minus 6 is 0. Now you're not done. I don't want 2x, I want 1x. And 0 divided by 2 is 0. Remember, it's 0 on the bottom is undefined. This one. So you go 12 times x plus 2, and I'm going to bring it over here a little bit just to have a little room. 4 times 6 is 24, so kind of skip a step there. So 12x plus 24. Wow! I didn't even try to do this. Subtract 24. 12x equals 0, so divide by 12, x equals 0. Now most of your answers aren't 0, just sort of happen. So this one, 5 times x equals 4 times x plus 1. So distribute the 4, 4x plus 4, subtract 4x. Hey, we have a problem that's not equal to 0. Yay! So hopefully you got those 3 answers. Another video